Hello Year 11 and welcome to what may be your first but definitely won't be your last maths video. I'm your teacher Mr. Stanwell, and hopefully I've introduced myself in class by now as well as how this whole process works. So we're going to jump straight into our first topic, Formulae and Equations. Now there is a reason that we're doing this first, and it is critically important to all of your other maths. Okay, there will be barely a single question that you'll do over the next 18 months, 2 years, that doesn't rely on the things that you're going to learn or revise, at least in this topic. Right, Formulae and Equations. You'll notice there is some terminology here, and hopefully you're familiar with all of those words. If you're not, check them out, look them up, then ask me, and we'll talk through any of those things that you're not entirely sure of. Now we're going to look at exercise 201 here, simplifying algebraic expressions. Now this is a very important topic, but much of it you will have done more than once over the last 4 years of high school. So, simplifying algebraic expressions, there are three things really here that we're going to ask you to do in this course. To simplify an expression doesn't mean to get a single number as an answer, right? An expression, right, doesn't necessarily have an equal sign, which means you can't necessarily get an answer as such. You can't evaluate it necessarily, but simplify it, make it smaller, make it simpler. Typically we'll do that by collecting like terms, multiplying terms, or dividing terms, multiplying and dividing, very similar. Now, like terms, certainly you've covered those in high school before, but quick recap, terms are a bit like words in a sentence. They're separated by pluses and minuses as opposed by spaces and full stops and commas and so on. But those terms, like terms, are identical except for their coefficients. That's the number out the front. Now, they can have letters in them, pronumerals, variables. They've got to have exactly the same power if they are to be like terms. Now, like terms are important because we can simplify them by adding and subtracting them. Let's have a look here. My first example, 5a plus b minus 2a plus 8b. Now, a little thing to remember is that the sign goes in front of the term. Okay, so I have a plus b here and a plus 8b here. I have a minus 2a here. Let's use a circle to indicate because they're not like terms. A minus 2a here, and this one here, what's in front? Plus, minus? Well, that's sort of like an invisible plus. So, my 5a and my negative 2a are like terms, so 5a minus 2a is, right, we leave the pronumerals there, the letter part, and I'm just basically going to do 5 minus 2 equals 3a, right? The a's don't disappear or anything, or we don't combine them in some way. I've got 5 of them, and then I subtract 2 of those things, so I have 3 of those things, a's, left. Okay, I've got a plus b, and plus 8b is plus 9b. So that's simplified. 3a plus 9b. Don't try to say it's like 12ab or something like that. Easy mistake to make, but most certainly a mistake. Now here's another one. This is a little more complicated. We've got a, sort of a product of multiple variables here, right? I've got x's and y's, and I've got some powers going on here too. Remember, this bottom part of, so this number out the front is the coefficient, this bottom number is the base, this is the power or the exponent, is my preferred word. So, have we got any like terms here? To begin with, don't worry about the number out the front, that's the coefficient, it's not that important, but x squared y, have I got any other x squared y's? This is just an xy, these are not like, right? Now I've got yx squared. Well, it doesn't sound like x squared y, but I can change the order. Remember that 2 times 3 is the same as 3 times 2. The order that I do multiplication isn't important, so I could just as easily write this as 2x squared y, which all of a sudden looks and sounds a bit like this term here. So the first and last terms are like. I've got 3 of this term. I am taking 2 of them away, leaves me with just 1 of them. Now I don't typically write a coefficient of 1, I just leave it off. Sort of assumed, in the same way that I might say I had 2 pies for lunch, or 3 pies for lunch, or 4 pies for lunch. Yeah, I'm a hungry man. But I don't say I had 1, I would just say I had a pie. Right? If it's 1, we tend to leave it off. So I'm just going to say I've got x squared y here. You wouldn't be wrong if you wrote yx squared as well. But, we tend to work in alphabetical order. So this is a little bit of a wacky question. So we've just got sort of like 1 x squared y here, and this here, xy, there are no terms that are like this one, so it's just going to hang around and do what it was doing before. So I've got x squared y plus 7xy. That's it, simplified. Rightio? So our first example. Now I said there are 3 things we've got to do. That's one of them, simplifying by collecting like terms. Second up, we're going to multiply terms. How do we do that? Well, you multiply the coefficients and you add the exponents, right? The exponents of the same base. Right, let's see how that works. Here we go. Now my coefficient, I've got -3 and 8. -3 times 8 is -24. So we can do that part 4 first. There's my -24. Now I have a b. Oh, actually I've got an a. There's an a in this term, there's no a here. I prefer to work in alphabetical order. So we've still got an a. Now I have a b in this term and a b in this term here. Now b times b, again, if I don't have an exponent, if I don't have any little number up here, it's like an assumed 1. So I do 1 plus 1 is 2. So my b to the power of 2, or b squared. Please don't say b2. b to the power of 2 is fine, or even b to the 2, but not b2. And then I've got a c here, no other c's there, so c here. Anyone speak Spanish? Never mind. There we go. So that's multiplying terms. Multiply the coefficients, add the exponents. Simple terms. Finally, dividing term. Oh no, sorry, I do have some more multiplyings here, some more examples. There's sort of some division going on here. Now, coefficients. Coefficient here is 4. The coefficient here is not really 3, it's 3 over 2. Even though it appears the whole lot's over 2, it could just be written as a 3 over 2 at the front. So, multiply those together. 4 times 3 over 2, 4 3s are 12, divided by 2 is 6. So there's my coefficient of 6. Now p squared times p to the power of 3 is, we add those together, p to the power of 5. Q, nothing else here. Q stays there, mind your p's and q's. 6, p to the 5, q. What happened to the 2? Well, it sort of cancelled out with that 4, I suppose. Right, 4 times 3 is 12 over 2. 12 over 2 is 6. Right, that's where that came from. P squared, p cubed. We add those together, not multiply them, because remember this means p times p. This means p times p times p. Altogether, that's p times itself 5 times. Yep, and the q. And finally this here, what does this mean? Well, we could write this as -5r times -5r. -5 times -5 is 25. Be careful, it's not -25. Negative times a negative is positive, r squared. Nice and easy. So now, as promised, moving on to dividing terms. How do we do this? Well, pretty similar to multiplying. Now, I do say there in the notes, you can multiply any 2 terms together. You can't actually divide or any 2 terms. Right? There are some rare exceptions. Can you suggest what that may be? Tell me in class, I'll find some sort of reward for you if you can think of that, right? What can you not divide by? Anyway, to divide the coefficients, subtract the exponents. Yes? All good, here we go. What do we got here? Now, essentially this is 8m cubed, or 8m to the power of 3n, divided by 2m squared. Okay, so my fraction there can be read as divided by. So, 8 divided by 2 equals 4. M to the power of 3, m to the power of 2, 3 minus 2 is 1. Now remember, I don't write m to the power of 1, I just leave it as m, and the n stays there as well because it is not divided by anything in the denominator. There we go, so 4mn. Nice. And here we go, 2 to go, and we will be finished our first video. So, -15 divided by 3 is -5. W divided by w to the power of 2. Now, there's more than one way to express this answer and in quite acceptable ways. Now, remember, this means sort of like a 1, this is a 2, 1 minus 2 is -1. So we could say it is -5w to the -1. We'll learn a bit more about indices later on. We'll review more about indices. Another way of writing this would be -5 over w. right? Either of these answers, perfectly acceptable. I don't mind at this stage which one you do. In fact, I probably don't mind further down the track which one you do either. Perfectly acceptable, either of those answers. Remember, divide the coefficients, subtract the exponents. And finally here, 6 over 20. I think we're probably going to leave our answer here as a fraction because 6 is not neatly divided by 20. Now, they do have a common factor, however, of 2, so I'm going to say that I have... I'm just going to start here. Divide the 6 and the 20 both by 2, and I get 3 over 10. That's not a 16, that's 10. 3 over 10. Now, I've got an A up the top, A down the bottom. They cancel each other out, right? And they sort of become 1 over 1, which I can just leave. Now, I have a... So don't worry about the A is gone. K to the power of 3 up the top, K down the bottom. So that's a 3 minus a 1 gives me K squared. So that's probably the nicest way to write your answer there is 3k squared over 10. I've drawn my little, I think that's called a vinculum. Whoops. I'm not sure what it's called. Anyway, that line in between separating them was a little bit long. 3k squared over 10. That's it. So, simplifying expressions doesn't mean to get some single number as an answer. It doesn't have to be one term. If you have a look at some of these answers here we've got, lots of them did end up as one term. But look here. Multiple terms. That's perfectly fine. That is simpler than what we began with. So, like terms are identical except for the coefficients. To multiply terms or divide, we multiply or divide the coefficients. We add or subtract the exponents. That's it for your first video. Hope you loved it. I will see you in class.